Example 6, kind of similar to example 5, we need to express the series in sigma notation. One thing that I like to do is to see if I can find the pattern between the numbers, and then I can write my general term. This appears to be, if we add 3, add 3, add 3, that appears to be just an arithmetic sequence or an arithmetic series. So to find the general term for this one, we can take the first term, which is 16. We can add d times n minus 1. Do the distributive property. We've got 3n minus 3. Combine like terms, and you've got 3n plus 13. Keep in mind that whenever we looked at this before, we always had n being 1 here. So if we write our sigma notation, we can just write n is equal to 1. The ending value we'll talk about in a second. Right here is the general term, so we can just write 3n plus 13. If you can guess at this and figure it out quickly, that's fine. If you are having a little bit of trouble with that, that's okay as well. Just take the general term, set it equal to the value of the last term that you want. So if we subtract 13 here, we get 3n is equal to, that looks to be right about 48. We can divide by 3 and n will be 16. So that's the value that's going to go up here. If we wanted to be a little tricky about this, we could use a different n value here instead of this 13. That would work as well. So there's many different ways to write this depending on what value of n you'd like to start with. You know, you could make this 3n plus 1. n would have to start at 5 then. So 3 times 5 plus 1 would be 16. So you could definitely do that in this case. Not totally necessary. This is just fine. This is a nice little arithmetic, and you can go with that.